Before watching this video, make sure that you have read the information provided under simple harmonic motion, because this problem is under it. For problem number 4, a force of 0.004 Newton exerted to a spring produces 3 centimeters increase in its length. When a mass of 8 kg is attached to a spring, find the period and frequency of the simple harmonic motion produced. To understand better, here is an illustration provided. A spring is mounted on a wall and it has this as its natural state. However, with a mass of 8 kilograms is attached into this spring, a force of 0.004 Newton is exerted that made it increase into its length for 3 centimeters. This one. Now, since this one is under simple harmonic motion, we are asked to solve for the period and the frequency. Since in the problem, it involves a spring, and if you go back to the formula provided on your module, there are certain formulas that we will be using in solving for period and frequency, depending if we are dealing with spring or a pendulum. And since we're dealing with a spring, we will be using this formula in order for us to solve for period, and for frequency, we will be using this formula. By merely looking at this, you can see that we have here the value of K. And if we will go back to the given, there is no value for K provided here. Therefore, it's necessary for us to be solving it first. And for us to solve for the value of K, if you still remember the formula a while ago, K is equals to F all over X. Now, for us to solve for K, we will substitute the value of your F. We have here 0.004 Newton all over the value of your X, 0.03 meters. Now, when we do the math, we will arrive with an answer of 0.13 Newton per meter. Therefore, this one is necessary, or you can write it here. The value of your K now is 0.13 Newton per meter. Alright, so let's now solve for period. Let's substitute the given. Period is equals to 2 pi, multiply it with the value of our M, 8 kilograms, all over K, the one we solved a while ago, 0.13 Newton per meter. So we have now 2 pi. When we perform this one, we will have 61.54 seconds squared. How did I get seconds squared here? Remember that Newton is also the same as kilograms times meter per second squared, all over M. And we have here on the numerator kilograms. Therefore, when we cancel the units, kilograms, meters, and seconds squared, we have here left. Okay, let's continue. Period now is equals to 49.29 seconds. That is the value of our period. Now let's continue with letter B, which is we will be solving for frequency. Frequency now is equals to 1 all over 2 pi, multiply it to the square root of K all over M. So let's substitute. Let's substitute the values. Frequency is equals to 1 all over 2 pi, multiply it with the value of our K, 0.13 Newton per meter, all over the mass, 8 kilograms. Now frequency is equals to 1 all over 2 pi. When we perform this one, the answer here is 0.13 per second. This means that in every 1 second, we have a cycle of 0.13. How did I arrive, or how did we arrive with this? Remember that Newton here is kilograms times meter per second squared all over meters, and we have here the unit of our denominator, kilograms. Cancel, 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 cancel. You have here second squared. Square root, therefore you can have now second here. So let's continue. Frequency now is equals to 0.02 hertz. Because if you will see this one, why it became hertz, that's the unit for frequency. In each cycle per second, we have 0.13. Now, this is the frequency.